In this presentation, I will be summarizing the article called Evolution of a Portable Markerless Finger Position Capture Device, Accuracy of the Leap Motion Controller in Healthy Adults. In this article, a team led by James Y. Tung tested the accuracy of the Leap Motion Controller for use in diagnosing, treating, and rehabilitating people with musculoskeletal and neural disorders affecting the hand and digits. The Leap Motion Controller was compared to the OptoTrack 3020. The OptoTrack 3020 is a very accurate measurement system that requires it to be attached to the body, unlike the Leap Motion Controller, which uses infrared cameras to detect position. The researchers displayed 15 square targets on the computer and had 9 volunteers point at the squares with the Leap Motion Controller tracking their position on the table below and the OptoTrack 3020 motion capture system attached to their finger. The volunteers would move their finger to the target's location when one of the 15 targets appeared. 2 variations of the test were conducted. During the first test, the volunteers would touch the screen. Then, in the second test, they would hold their finger 4 centimeters away from the screen. The 4 centimeter distance was forced by temporarily putting a 4 centimeter ball between the finger and the screen before removing it. With 15 targets and 2 tests, there was a total of 90 trials. However, touching the screen provided unreliable results, with 56% of the trials giving data that was deemed unusable. As a result, the last 4 volunteers were only tested using the 4 centimeter distance method. The measurement results from the Leap Motion Controller and the OptoTrack 3020 are as follows. The Leap Motion Controller measured on average 17.3 plus or minus 9.56 millimeters away from where the OptoTrack 3020 measured. The targets that were further from the center provided less viable data. Of the 450 trials, 244 were viable. The mean difference between the 2 measurements were 2.39 millimeters horizontally and 0.37 millimeters vertically. Tung and his team wished to test the Leap Motion Controller on its accuracy to see if it would help people with musculoskeletal and neural disorders affecting the hands and digits. However, it provided too inaccurate to be used for detailed procedures. The Leap Motion Controller may be used for basic clinical assessments. The Leap Motion Controller can collect a large quantity of quality of information compared to other more expensive equipment. Inaccuracies may be overlooked because of the large amount of data collected for the equipment's comparatively low price of $80.